Let's start with a recap of Lesson 3.1, Introduction to Slope. In the previous lesson, you were introduced to the concept of slope, which is m equals rise divided by the run. Slope, rise, and run are inherently tied to triangles. Therefore, we will have to review needed background trigonometry in order to move forward with the examples. And we'll do that in class example 1. So in the triangle below, we are going to use Pythagorean theorem to find the unknown side x, and we will also calculate the tangent ratio. So a reminder, Pythagorean theorem is a squared plus b squared equals c squared. If we need to, we can label the triangle with A, B, and C. And now that we've done that, we can replace the letters with the known values. 4.3 squared plus 1.9 squared equals x squared. Your next step will be to type the expression on the left side into your calculator, which if you do so, you will get the value 22.1 equal to x squared. And finally, to finish the calculation and to find x, you need to square root both sides. And you will end up with 4.7 centimeters. Now, the next thing we need to do is calculate the tangent ratio. And a reminder that tangent from angle, any angle, is the opposite side divided by the adjacent side. So, for this triangle, when we are looking at theta, we will label side B, 1.9, as the opposite, and 4.3 as the adjacent side. We place those values into the formula. Tan theta equals 1.9 divided by 4.3. Now, if you remember, this is where it is a little bit strange. You have to use the tan inverse button on your calculator to actually get the angle theta. So when we write it down, it looks like this. Your angle is equal to tan inverse and then 1.9 divided by 4.3. I will pause for a moment, or you should pause the video and just make sure you can type and calculate tan inverse, find that on your calculator, and practice to make sure you can get this answer. Theta equals 23.8. Pause the video for 15 to 30 seconds and make sure that you can calculate that value. Now, a lot of the problems in today's lesson will feel like trigonometry problems, and essentially they are. There's not much going on that's different from our trigonometry unit, except there's a few key things that you just need to know, and it mostly is vocabulary. So I'm going to remind us here, and I'd recommend you write it into your page as well. So the key things to remember or to know are essentially that rise is the vertical distance, Remember that run is horizontal distance. Remember the slope formula, or the fact that slope is rise divided by run. And then lastly, a reminder that angle of elevation is the angle between horizontal looking up. And if we have those 4 key pieces of information, then we are able to use slope and find the calculations of slope anytime it's coming up as a triangle. So in this next example, we have 2 tasks: calculate the slope of the hypotenuse and find the actual angle of elevation. Let's start with slope of the hypotenuse. Slope of a hypotenuse, well, remember slope, that's rise over run. Slope is rise divide run. And here we're bringing in the key pieces of information. Rise is the vertical distance. This one's the vertical. Run is the horizontal. So we have our 2 values that we can put into our calculation. 12.6 divided by 28.4, which becomes 0.44. Now, for angle of elevation, we need to place it first into the triangle. And if this is my horizontal here, horizontal being the run, the angle of elevation will be up from the horizontal. Placing it there. So, now that I've placed my angle theta, I call this the opposite. Call this the adjacent side, and opposite divided by adjacent is a tangent. We kind of recall SOHCAHTOA just as a reflection. I'm using the opposite and the adjacent in this calculation, and so that is telling me tangent is the formula to use. So tan theta equals opposite over adjacent. Pause the video and spend the next minute or two to calculate the angle theta. You can check your answer after you've given it a try. Take a moment now to check your solution or your answer and make sure you've got the same angle that you see here. If you don't, pause the video and reflect on the work that you've done to find out what went wrong and what you need to correct. Just to reflect before we move on to the last class example, what we've done here is, if we have a triangle, a rise and a run, then we can calculate slope, we can calculate angle of elevation. Now, the next example is somewhat going backwards, and on the surface it actually is pretty straightforward. A slope has an angle of elevation of 23 degrees. So we have a slope has an angle of elevation of 23 degrees. Calculate the slope to 2 decimal places. The key thing to understand here is that tangent from 23 degrees is the slope. I'll explain that in a little bit more detail up in the corner here. Why does it work out this way? Well, if we have a triangle with 23 degrees here, well, this would be the rise and the run. Other words we use are opposite and adjacent. So, tangent from 23 degrees is the opposite over the adjacent, or better yet, you could call it the rise over the run. And we know that rise divided by run is slope m. If I may have gone a little bit fast there, but once you have it written down, just think on it and see if you can make sense of what's going on. The actual calculation, you're just going to place tan 23 into your calculator, and you will get the value 0.42. That concludes the teaching portion of this lesson. Please spend the rest of the class completing the on my own problems, and do not forget to check your answers as you go. Good luck.